You clicked because you heard about a massive memory price surge, and that report is real. Since September, NAND flash contract prices have jumped 600%, while DRAM costs have climbed 400%. This is not a minor fluctuation. It is a physical bottleneck that is forcing engineers to choose between the AI features you want and the raw storage capacity you need. By the end of this explanation, you will understand exactly how manufacturing yield issues are rewriting the rules of device design. Let us start with the raw numbers because they tell a story that financial headlines often miss. The 600% increase in NAND flash is not a uniform market shift affecting every single chip equally. It is concentrated in specific high-end enterprise contracts and short-term spot market volatility. However, the 400% rise in DRAM is broad enough to impact the entire consumer electronics supply chain. When you look at the bill of materials for a modern smartphone or laptop, memory is no longer just a commodity. It has become the most expensive variable in the equation, and the math is no longer adding up for the old business model. The root cause lies in the factory floor, specifically in the transition from older manufacturing processes to new ones. The industry is currently retooling its 200mm wafers to support 3D NAND stacking, a necessary step for higher density storage. This transition has created a severe yield bottleneck. When you are building a new type of chip, the initial production runs have low yields. You might get one good chip for every 10 attempts. This scarcity drives prices up exponentially because the supply cannot meet the demand for the high-performance memory required to run large language models. Here is the thing that most consumers do not see. This physical scarcity forces a binary choice in device engineering. You can either reduce total storage capacity by 30 to 50% to maintain profit margins, or you can absorb the massive cost increase and cut the AI feature sets entirely. For many manufacturers, the second option is not viable because on-device AI is now the primary selling point. They cannot compete without it. So, they are choosing the first option. They are shrinking the local storage budget to make room for the expensive memory needed to cache AI models. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This creates a new trade-off that we are calling the capacity versus performance dilemma. In the past, a consumer would buy a device based on how many gigabytes of storage it offered. You wanted 500 gigabytes so you could store thousands of photos and videos. Now, that metric is becoming less relevant. Engineers are prioritizing high-endurance, lower-capacity enterprise-grade NAND for AI model caching over bulk consumer storage. The result is that local large language model context windows are being capped to preserve margins. You might get a phone with less total storage, but the memory it does have is being used more intelligently. The impact on DRAM is even more immediate and visible in performance metrics. The 400% price hike has triggered what engineers call a memory wall trade-off. In previous generations, devices could afford to dedicate specific VRAM to AI accelerators. This allowed for fast, real-time inference without slowing down the rest of the system. Now, with memory so expensive, manufacturers are replacing dedicated VRAM with shared system memory. This sounds like a minor change, but it introduces significant latency penalties. Consider the real-world impact of this shift. In edge scenarios, where a device must process data locally without sending it to the cloud, the latency penalty degrades real-time inference performance by 15 to 20%. This means that when you try to use an on-device voice assistant or an image upscaling feature, it takes longer to respond. The system has to wait for the shared memory to become available because it is being contested by other tasks. The device is still doing the work, but it is doing it slower and with more power consumption. This economic pressure has accelerated the adoption of a new architectural pattern known as tiered storage. In this model, hot AI data is moved to expensive, low-latency DRAM and NAND tiers, while cold data is offloaded to compressed cloud storage. This fundamentally alters the software stack's input and output handling. Your device is no longer a standalone island of storage. It is a hybrid system that constantly balances local speed with cloud capacity. This shift also changes battery consumption profiles because moving data to and from the cloud requires radio activity, which drains power faster than accessing local memory. To cope with these constraints, engineering teams are now prioritizing storage-aware model quantization strategies. This means AI models are being aggressively pruned to fit within the constrained, expensive memory budgets. Developers are removing unnecessary parameters from the models so they can run on the smaller, cheaper memory configurations. This is leading to a divergence in device capabilities. Budget devices are losing all on-device AI features because they simply cannot fit the pruned models into their limited memory. Premium devices retain these features, but often at reduced precision. The trade-off is between having a feature that works perfectly and having a feature that works adequately on a cheaper platform. The narrative of a uniform price hike is too simple. The 600% NAND surge reflects specific high-end enterprise contracts or short-term spot market volatility rather than a uniform consumer shift. The financial datasets show memory price increases capped at 90% in the fourth quarter of 2025 for the broader market. However, the engineering reality is that the pressure is real and it is driving immediate hardware redesigns. We are seeing a shift towards smaller-based storage models with cloud-dependent AI offloading rather than a complete halt in local storage expansion. This situation reveals the manufacturing realities behind the price tag. It is not just about supply and demand in a vacuum. It is about the physical limitations of retooling factories for 3D stacking. Until yields improve, the cost of memory will remain high, and the trade-off between AI features and storage capacity will persist. Consumers will need to adapt their expectations. Buying a device is no longer just about checking the box for storage size. It is about understanding how that memory is allocated between raw capacity and intelligent processing. The industry is moving toward a future where storage is not just a number on a spec sheet. It is a dynamic resource that is allocated based on the complexity of the tasks the device is performing. As the manufacturing process matures and yields improve, we may see prices stabilize. But for now, the physical bottleneck is dictating the design of the devices in your pocket and on your desk. The 600% surge is a signal that the era of cheap, abundant memory is over, and the era of intelligent, constrained memory has begun. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.